Hello grade 8s and welcome back to MV Tutors. Today we're going to have a look at exponents even more. Alright, so we're going to look at numbers in exponential form. Now let's just recap a little bit. Last time we looked at squares and we looked at cubes and square roots and so forth. So now today let's look at what an exponent is. Let's look at the definition. So an exponent is a number to which an integer is raised. Remember an integer? We go from negative infinity to positive infinity. They are like natural numbers, but with a negative as well included. So it's not fractions or decimals, it's just a whole number, a natural number, but we can consider the negative side to it. Okay, hence I say from negative infinity to positive infinity. So it is an exponent is a number to which an integer is raised. So an integer can be negative 5 to the power 2, for example. Okay, and it indicates the number of times an integer is multiplied by itself. So if we're going to say minus 5 to the power 3, it means that integer minus 5, if it's to the power 3, it means that those are the number of times that integer is multiplied by itself. So we're going to get minus 5 times minus 5 times minus 5. All right. So an example that I have here, 5 to the power 6. 6 is the exponent. 5 is the base. So what are we doing? We are taking that 5 and we are multiplying it by itself 6 times. So we have 5 times 5 times 5 times 5 times 5 times 5. And if you check on your calculator, 5 to the power 6 is indeed 15,625. All right, so while we're at it, let's do a little bit of an exercise. Exercise 3.2. Write the following in exponential form. So according to our definition, let's go back again. It says an exponent is a number to which an integer, in this case the integer is 2, is raised. All right. Now what is the power then? How many times did the 2 multiply by itself? Okay, so the base here is 2 and we can see that it's multiplied 4 times. So we're going to say 2 to the power 4. All right, simple enough, right? B, the base is 4. All right, this is our exponent. This is our integer. All right, and how many times is it multiplied? It's multiplied twice, so we're going to say 4 to the power 2. And the last one, number C, so we see that our base is 6, our integer is 6. And how many times has it been multiplied by itself? Well, 1, 2, 3, 4, 5, 6, 7. So it's going to be 6 to the power 7. Okay, so that is how we write these numbers in exponential form. Now, the second part of this exercise is to expand the following. All right, so if it's 3 to the power 6, it means we are multiplying 3 by itself 6 times. So 3 times 3 times 3 times 3 times 3 times 3. Okay, just make sure you don't overwrite or underwrite. Just make sure it's 6 threes. All right, and they said expand the following. They didn't say get the solution, so we're not gonna work it out what 3 to the power 6 is. That's not necessary. And then for B, we have the integer minus 5 and it's multiplied 4 times. So minus 5 times minus 5 times minus 5 times minus 5. If sometimes it confuses you to see a multiplication and a subtraction sign next to each other, you can always put it in brackets. Okay, brackets are actually your best friend in maths. They help put things into perspective. Now, see, 8 to the power 7, it means our integer is 8, and we are multiplying 8 by itself 7 times. So, 8 times 8 times 8 times 8. Okay, so I've written it 4 times, and I'm going to write it 3 times. 8 times 8 times 8, and there it is, 8 to the power 7. And the last one, we have negative 2 to the power 3. So negative 2 times negative 2 times negative 2. There it is, 3 times. Okay, and let us now apply our skills. So now we need to insert the correct symbol. All right, do we have smaller than, equal to, or greater than? I see here I used the same. So this should be greater than. Okay. So which one are we going to use now? First one, A, we have minus 4 to the power 3. So that's basically minus 4 times minus 4 times minus 4. And that should give us minus 64. Okay, so we see that is minus 64. So you can write it for yourself somewhere. So minus 64 and 64, are they equal? Definitely not. Minus 64 is smaller than 64. So the bigger one is 64. Okay, 64 is greater than minus 64. Now we have 3 to the power 4, all right, times 4 to the power 3. What is 3 to the power 4? Ooh, 3 to the power 4 is 81. Okay, and we are multiplying this 81 with 4 to the power 3. You can actually just put everything in the calculator at this point. You don't have to look at it individually. But 4 to the power 3 is 64. So what is 81 times 64? It is 5,184. Okay, 5,184. Now I'm going to just put the rest in the calculator. 4 to the power 3 multiplied. We already know 4 to the power 3 is 64. Multiplied by 3 to the power 3. 3 to the power 3 is less than 3 to the power 4. So we already know that this is bigger. But anyway, let's continue. 3 to the power 3, that is 1,728. So definitely that is smaller than 3 to the power 4 times 4 to the power 3. All right, now we have 6 to the power 2 multiplied by 2 to the power 3. And that is 288. Then we have 2 to the power 6. And we are multiplying it by 3 to the power 2. So that is 576. So we know which one is bigger. There. Then we have negative 3. So we're going to put it in brackets. Negative 3 squared multiplied by 4, that's 36, and we have 34 there. So yeah, there we go. All right, this exercise was nice. And then now we are getting to the laws of exponents. It's very important to understand these laws so that you can apply them and it makes life a little bit easy. Okay, this is the last part we're going to look at while we are dealing with exponents. Okay, so the first law of the exponents basically says when multiplying the same base, you add the exponents. Guys, this is important. You will carry it through until matric and beyond. Okay, so if we have the same base, we are going to add the exponents. Let me use a different color then. So we have the same base, which is a, and then we're going to add the exponents, which is m plus n. Okay, that's it. When we divide the same base, we subtract the exponents. Okay, so we have a base there. You see, we have the same base, but now we are dividing these bases. So we are subtracting the exponents. So we're going to say m minus n. Okay, sometimes yeah, actually this is exactly how you write it. So just be careful when you're dividing. Even if they put it like this, a to the power n divided by a to the power n, it's the same. You can say a to the power m minus n. So with multiplication we add, with division we subtract. Now rule number 3, okay, or law number 3. When a power is raised to a power, you multiply the exponents. Okay, so we can see a to the power m to the power n. So you have your base there as a, and if you have a power raised to a power, we're going to multiply the powers. We're going to multiply the exponents. Okay, so basically you're going to get a to the power mn. Please do not forget this. Now 4, when dividing different bases with the same exponent. Okay, so we can see we have the same exponent n. Divide the bases. Okay, so we're going to divide the bases. And write the quotient. So the quotient is a over b. Remember another word for division, we can say quotient. Another word for multiplication, we can say product. Another word for addition, we can say sum. Another word for subtraction, we can say difference. So we're going to take those bases and write the quotient with the same exponent. So there, that's what it means. Okay, I didn't want to write it like this because now you're going to think it's just a to the power n. Hence, I put the brackets around it. That's why I'm saying brackets are your best friend when it comes to maths. All right. Now, number 5. When multiplying different bases with the same exponent, you multiply the bases. So we have a times b. And write the product with the same exponent. Okay, so basically we just have ab to the power m. Okay, and those are your 5 laws of exponents. So now let's go look at an exercise just to go and practicalize what we have read and understood. Okay, so yes, exercise 3.3, calculate the following. Just going to use a different pen color. So we have the same base here. For 1a, we have 3 to the power 3 times 3 to the power 3. So we have the same base. What are we going to do to the exponents? We're going to add them. So basically, it's 3 to the power 6. And now we are dividing. So we have the same base, 3, and then 4 minus 2. Okay, because if you are dividing, we are going to subtract the exponents. So ultimately, you're going to have 3 to the power 2. Okay. Yeah, if they want the final answer, let's just do it. What's 3 to the power 6? 729. And 3 to the power 2, that is just 9. All right, and then 3 to the power 2 times 9. Well, 3 to the power 2, we can write 9 as a prime base. So 9 is 3 times 3. So if we have 3 times 3, we have 3 to the power 2. So now 3 to the power 2 times 3 to the power 2. Remember, same base, add the exponents. So we have 2 plus 2, which is 3 to the power 4, which is simply 81. Okay, so yeah, that is basically that. Multiplying with the same base, you add. If you're dividing, you subtract. Now let's get to 2. So 2a, we have the same base again. We can add the exponents. So 2 plus 3. So you can just go ahead, a to the power 5. And then b, we are dividing. So we have the same base. And then we can say 6 minus 3. So now it's a to the power 3. And then you have a power raised to a power. Remember what we do with that? We say a 2 times 6. You have a power raised to a power. You multiply the exponents. And what is 2 times 6? It's simply 12. All right. And that is it. That is it for our lesson today. I hope you learned quite a lot. Like I said, this is very important. This is a very important lesson. You're going to need this. Okay. It doesn't just end here. All right. So that is it. And see you next time.